Hello everyone, my name is Hooman Khosravi and I'm here to present the paper I co-authored with Katayoon, Etemad and Faramarz Samavati. Our paper was titled Simulating Mass in Virtual Reality Using Physically Based Hand-Object Interactions with Vibration Feedback. Here we go. Virtual reality, or VR in short, enables immersive simulated experiences. Moreover, in VR it is also possible to interact with visual objects. However, virtual objects in VR do not have real masses, and it's difficult to sense their weight. Researchers have proposed different techniques to give a sense of mass to visual objects. One group of methods focus purely on vision-based illusions, for example, adding a velocity limit or tweaking the control display ratio between the user's actual and the user's virtual hand. Another approach is using haptic feedback, for example, using a motor or asymmetric vibrations to create a skin stretch effect. Now, our method for mass rendering is using a physically based visual hand. This visual hand is made from multiple rigid parts which are coupled using visual spring dampers with their corresponding parts in the user's actual hand. This allows a user to pick up an object without the visual hands penetrating it. Now, picking up a light object requires less force. So when using this hand, you can use less fingers or maybe a bit more relaxed hand pose to pick up a light object compared to picking up a heavy object. We suspect such cues enables the user to get a sense of mass from the objects they're interacting with. One potential problem for this is, what if the two objects are both very light? It would be easy to pick both of them up, even though they may have a significant weight difference. Therefore, we propose a complementary sinusoid vibration feedback. When the user is grasping an object, the vibration renders at their index fingertip, and its intensity changes proportionally to the object's mass and acceleration. So the heavier an object is, or the faster they try to accelerate it, the more powerful the vibration will be. Also, the frequency of the signal modulates from 100 to 150 Hz based on the object's velocity. Our skin cannot detect the direction of vibration in these frequencies, therefore one actuator is sufficient to render the mass in all directions. To evaluate our method, we conducted a user study with 10 participants, in which they performed multiple sorting and comparison tasks using 3 different interaction modes. A control mode using a spherical cursor, the visual hand with no vibration, and the visual hand with vibration. For the sorting tasks, we split our mass range into a lightweight set and a heavyweight set to analyze the performance of our methods across a wider mass range. We can see the result of the sorting task in the form of 6 confusion matrices. From left to right, we have the results for the spherical cursor, visual hand with no vibration, and visual hand with vibration. Furthermore, the top row is for the lightweight set and the bottom row is for the heavyweight set. In these matrices, the higher the numbers in the diagonals are, the better the sorting accuracy is. Here, the green matrices show statistically significant sorting results, and the red matrices means participants could not sort the objects meaningfully in those scenarios. As we can see, using the vibration feedback, participants were able to sort the objects in both light and the heavyweight sets. And with the hand and no vibration, they only could sort the heavier objects, which are harder to pick up. Participants also expressed in the questionnaire they could perceive and discriminate objects' masses when using the visual hand with the vibration effect. Also, they found it to be more realistic and interesting in a gaming experience. But they were mostly neutral about using the visual hand without the vibration, even though data showed they could sort objects in the heavier weight ranges. To conclude, objects in VR do not have real masses, so we proposed using a physically based VR hand and a vibration feedback to complement it to render mass in VR. Using the physically based hand and the vibration feedback together, users were able to sort objects across a wide mass range and regarded the experience as realistic and interesting to see in a VR game. Thank you for your attention. That concludes my presentation.